Hello, this is a review for test 2 in Math 123, Quantitative Reasoning. The executives at Hydrate, a soda and energy drink company, conducted a quarterly review of the company's production facilities. For the review, the number of work stoppages due to mechanical failure were counted at each of the company's bottling plants. The histogram below summarizes the data. Use the histogram to answer each of the questions. Okay. So we can see along the horizontal axis, we have the number of work stoppages. The vertical is the frequency, and the frequency is the number of bottling plants. Okay, when they ask the first question, what is the class width? You want to take the difference of the lower bounds of the first two classes. So I'm going to take 11 minus 4, and I get 7, and that's the class width. That's not the only way to do it. You could have also done, the 17 minus the 10. That would have done it. Um, but you can't just take the upper bound for one and subtract the lower bound. You're going to be off by 1, so definitely don't do that. Okay, a lot of people mess up on that and are off by 1, so don't be off by 1. Make sure it's the lower bound of the first class minus the lower bound of the second class. Okay, how many bottling plants had 17 or fewer work stoppages? So we're looking for work stoppages to be less than or equal to 17. So 17 or fewer translates into less than or equal to 17. Okay, uh, so work stoppages, that's this horizontal axis. Okay, and we're about to be reading these, so it might be nice if we have them labeled. And if you want, that could be the very first thing you do before you do anything else. Okay, so now 17, if we look along here, here's our 17. How about that? And we want fewer than 17. So, 11's fewer, 10 is fewer, 4 is fewer than 17. So we're definitely going this way. So to add these up, I'm just going to take 5 plus 1, or 1 plus 5, either way. So we have 6 bottling plants had 17 or fewer work stoppages. Okay, one class is most frequent. How many bottling plants are in this class? So look at what the question is asking for. How many bottling plants are in the class? Okay, so the most frequent class is the one with the tallest bar. And the height of the bar is the frequency, the number of bottling plants. So the answer to this question is 7. Okay, I was trying to get rid of that little thing there. I'll just put a 7 and be done. Okay. Uh, so if you said, 18 to 24 and then said 7, that's fine. As long as you're saying how many, which is 7. Okay. Okay, and it appears. Okay, number 2, draw a histogram for the data below using an initial class boundary of 16.5 and a class width of 5. Label each class with its endpoints. So we have some data, we have where we're going to put the histogram. Now, before we make the histogram, I would recommend making a frequency table. So they've told us what the boundary and the width is going to be. So we have class, then we're going to need some tally marks, and then we're going to figure out what the frequency is. So the first class is going to be from 16.5 to something. So we'll just leave that blank for the moment. And notice that it ends in a 0.5. So whatever we find for that lower bound of the second class, we'll actually just copy over instead of subtracting 1. So I'm going to take the 16.5 plus that width of 5 to get 21.5 for the next lower bound. And then I can just keep counting up by 5. I want to make a note of, it looks like the biggest one I can see in there is 37. So once I have something that can contain 37, I'm going to stop. So 31.5. And then if I add to that, I get 36.5. So that last one I wrote down, that should hold the 37. And now since this is the other kind of histogram, these endpoints match up. And then I can add 5 to the 36.5 to get 41.5 for the last one. Okay, I'm going to zoom that out a little bit. Okay. So the long and tedious part here. So you can pause the recording and do that part on your own if you want. Okay, once you have the tally marks, add them up. And then we can build our histogram. So with this style where it's ending with a 0.5 and we're working with data that are whole numbers. So I'm just going to make a tick mark, and that tick mark gets a single label. So I'm not labeling in between like I would with that other style that we saw in problem 1. Okay, so the first bar is going to have a height of 7. The second one's going to have a height of 6. Then 2. Then 5. Then 1. All right. So the deliverable for this question at the end is the histogram. Uh, and if you're able to look at that and make a histogram straight out of your head, you're amazing. But I need to make that little frequency table first. And question 3, each of 7 students reported the number of movies they saw in the past year. Here's what they reported. Find the mean number of movies that the students saw, if necessary. Round your answer to the nearest tenth. So 11 plus 9 plus 9 plus 4 plus 5 plus 11 plus 9. I don't even have to count them. Oops, because they already told me it's supposed to be 7. You can count them, double check that you didn't forget anything though. Okay. So I get 58 over 7 to the nearest tenth. I get 8.3. Here are the weights in pounds of a sample of 9 male 11th graders. Find the median weight for these students. To find the median, we first must sort. So find the smallest thing. And then go from there. And then 171, 173. If it's supposed to be 9, then you can add 1 to that, divide by 2, and you'll know it'll be the 5th item in the list. Otherwise, you can just work your way to the middle using your fingers or underlining like this, back and forth until you get to a middle 1 or a middle 2 items. So my median is 161. Okay, here are the number of children in 10 elementary school classes. Find the mode or modes for this data set. You could sort the data or you could make a frequency table, whichever you like. If you make the frequency table, you kind of have to look through there and see if there's a smallest thing and a biggest thing. So let's see. Or you can just sort. Either way is fine. So frequency table works. I'm gonna just sort this time around. It's all a matter of how much you trust yourself at the time that you're trying to do it. Okay, I don't see any repeats. That means that there's no mode. Okay, the following summarizes the number of fiction books read last summer by a sample of 28 students at a certain college. What is the mean number of books read? Round your answer to the nearest tenth. So we have just a regular frequency table. We don't have anything grouped. So we have one column number of students, one column number of books. and they're asking for the mean number of books read. So my final answer is going to be in terms of books, which means that I'm going to be dividing by the number of students at the end of the day. And the other hint here is that they typically in these types of questions will give us the total frequency. So they already gave us the total for this column. This one, you're not going to do anything with. You're not going to add that up. But those numbers are going to go into the product. So we're going to make a product column. So I'm going to take 6 times 2. So I'm just multiplying all of these out. 6 times 2, 10 times 3, 12 times 4. So I have 12, 30, 48. And then I want to add those up. So I get 90. And then to the nearest 10th. Okay, so I want to add up the products and get the 90. And then I'm going to divide by the total frequency, or the total of the frequencies. So I'm going to take 90 over 28. And to the nearest 10th, I'm getting 3.2. And don't forget your sanity checks. So your final answer, right, it's the mean number of books read. So my 3.2 better be somewhere between the lowest number of books and the highest number of books. So 3.2 is between 2 and 4. So I'm happy. Okay, some researchers developing a new intelligence test are trying to decide how much time to allow to complete the test. Okay, number 7. Some researchers developing a new intelligence test are trying to decide how much time to allow to complete the test. The researchers have recorded the times in minutes for completion of 28 people who took the test for practice. The frequency distribution below summarizes the completion times recorded by the researchers. I have a column for time for completion in minutes and then a frequency column. And I can see that this is grouped data because I can see 9 to 11, 10 to 14, I'm sorry, 12 to 14, et cetera, et cetera. So with this, I'm already expecting that they're going to be asking for a mean. So let's finish reading through. So based on the frequency distribution, using the midpoint of each data class, estimate the mean completion time of the people who took the test. Round your answer to the nearest 10th. Now, if you are fully reading the question and they give you a sentence like this that has this little statement in it, they're giving you a huge hint. They're reminding you that you better be finding the midpoint. So I'm going to be tacking on 2 additional columns here. So I'm going to be tacking on a midpoint column and then a product column. Now to find the midpoint, I take the lower bound plus the upper bound and I divide by 2. So I'm going to take 9 plus 11 and then divide by 2 and I get 10. Okay, and you can go through the entire chart doing that, but what you could also do is just notice what the class width is. So the class width, I can take 12 minus 9 to figure that out, and I get a class width of 3. So once I have that first midpoint, I can just add the class width all the way through to get the rest of these. So plus 3, plus 3, plus 3, and plus 3. Now, if you find the first two midpoints and subtract them, that will also give you the class width. Okay, and then once you have all of the midpoints, that's when you're going to make the product column. So the product column comes from multiplying each one of these out. And then we're going to add up just two of these columns. Okay. So 80, 104, 96, 95, 22. And then it doesn't make sense to add up that first column. The frequencies I want to add up, and they better add up to 28. And I say that because they already told us that there were 28 people, right in the question. The midpoints, you do not add those up, but you do add up the products. And when I add those up, I get 397. And then to get the mean, now this is just an approximate mean because this is group data. So the mean is approximately 397 divided by 28. And to the nearest tenth, I have that it is approximately 14.2. And does this make sense? So we're trying to find the mean completion time. So if we look at the time for completion column, the lowest that they have listed is 9, the highest is 23, the 14.2 falls in there. Okay, now number 8, if you see a question like this on the test, you're not actually computing anything. You're just choosing which type of average would be the best one to use in this situation. So here are the prices in thousands for 9 houses for sale in a local neighborhood. And then look through the data, and what we're looking for are outliers. So I have 159, and then it jumps to 287, and then doesn't go too far to get to 295, et cetera, et cetera. I don't see any other jumps. So this is an outlier because I have to go quite a ways to get from 287 or to get from 159 to 287. If we have outliers in our data, then if you are trying to actually find the typical case, median might be a good option for you. Okay. Now it's somewhat hard to determine. So some of these might have kind of a best answer, and in some cases there might be a second best answer. But look for outliers. If it has outliers, pick the median. If it doesn't have outliers, pick the mean. If it's talking about something that's most frequent, choose the mode. So Teresa wants to determine which letter appears the most often in her favorite poem. Which measure should she use? Well, keyword there is most often. So you're going to go with the mode. In the past 10 days, Christine received the following numbers of email advertisements per day: 40, 41, 44, et cetera, et cetera. And then you can see it's not going very far to get to each of the different values. There's no huge jumps, so I don't see any outliers. So no outliers. So we're going to pick the mean. Now, what would be wrong with the median? Nothing. But uh, I'm just I'm going along with the test material I have, and kind of what they toss at you in Alex. But to be quite honest, mean or median is perfectly fine for part C. A, it's kind of situational as far as whether you choose to do the mean or the median. The median is going to ignore that one outlier, basically. The mean will account for that outlier. And it really depends on, what you're trying to communicate with the data. And if you want to be completely honest with how you're communicating about the data and summarizing the data, report all three types of average. Hey, the Dallas Cowboys football team is known as America's team. I don't know why. Uh, I don't know. I don't watch football, so uh, we survey a group of 2,957 people and find that 38% of respondents say the Dallas Cowboys are their favorite team. Uh, where did they get these people? What is the margin of error for this survey? Write your answer as a percentage, rounded to the tenths place. And then what is the 95% confidence interval for the survey? So the margin of error formula is one of the formulas that you get off of the formula sheet. And it's the plus or minus 100% over the square root of n. For this particular survey, we had n was 2,757. So then my margin of error is going to be plus or minus 100% divided by the square root of 2,557. So to the nearest tenth, I have plus or minus 1.9%. Okay. And if you report it without the plus or minus, that's fine. As long as you do that calculation correctly and you know it's a percentage straight out of the calculation, rounded correctly. So 1.9% or plus or minus 1.9% will be fine. And then the 95% confidence interval. Now in this case, I just need you to give me the confidence interval. You don't have to do the sentence. But what we're doing is we're taking that 38% and we're adding and subtracting the 1.9%. So that's two separate calculations. That plus or minus is just a shorthand way to say we're going to add it, then we're going to subtract it. So I have 36.1%. And I have 39 39.9%. So then my confidence interval is 36.1% to 39.9%. Okay. If you wanted to make a sentence, we can be 95% confident. And then that 95% in this context is just a black box. You just say it. You don't do any calculations to come up with that. That's just the type of interval that we've been talking about. That the true percentage, so I'm just going to assume that the people surveyed for this were just Americans, as in Americans from the United States who say the Dallas Cowboys is their favorite football team is between 36.1% and 39.9%. Okay. All right. Quite a mouthful there. But if I just ask you for the confidence interval, all you have to do is that first calculation. In a recent survey, 8 college graduates were each asked for the number of hours they work each week. Here's a list of the responses. Find the range of the data set. So range is the maximum value minus the minimum value, or the biggest minus the smallest, however you want to phrase that. So I search through here and then I see 54. Is there anything bigger than 54? Looks good to me. Looks like the max is 54. Minus. Smallest, is the smallest 40? Oh, I found 39. Is there anything smaller than 39? No. Well, then I'm going to do 54 minus 39. So I get 15. Okay, the test scores of the students in 4 classes are summarized below. Answer the questions about them. So based on the information above, which classes' scores have the most variability? So variability, so most variability means, so we have the range statistic and the mean statistic. So most variability would be the biggest range. So what's the biggest range? Looks like 31. So, and it's asking which classes scores, right? So this is class D has that. Okay, based on the information above, which class has the highest scores on average? So highest scores, that would be the biggest mean. So which one is the biggest mean? I see the biggest mean is 101. Okay, well, where did I get that? Class C. Okay. The following are the PE ratios, so price of stock divided by projected earnings per share for 18 banks. Find the 10th and 17th percentiles for these ratios. So in this case, this is the situation where we're working backwards. I'm going to go ahead and sort the data, and you can sort it however you'd like. Or you could use other means, but the best kind of big hammer for this is just sorting it. Okay, so I went ahead and I did the boring stuff off of the recording. So I've sorted the numbers in increasing order, and I've indexed them in that I have gone ahead and just labeled each one of them with a number counting up from 1. While I index them, I see that my last index is 18, which tells me that I at least have the correct number of numbers written down. Now, to find the values at the 10th and 75th percentiles, I have to calculate some L values first. So my L, I take the number of items times the percentile written as a decimal. So 10th percentile is 10%. Writing that as a decimal, I get 0.1. And then when I multiply that into 18, I get 1.8. And then I'm going to, this is the always round up situation. In this case, it would have just rounded up to 2. So then, so this is the 2 index. Since I didn't get a whole number, okay? So now I just take the number at the 2 index, which is this 15 here. So then I would say 15 is at the 10th percentile. Okay. Second one, I'm going to take 18 times 75 percent written as a decimal, so times 0.75. Okay. So let's see. So I'm getting 13.5. Hold on, let me think about that. Yeah, 13.5. Okay, and then I'm going to round that up to 14 because this is also not a whole number. So in this case, it's going to just be at the 14 index. Now, if I would have gotten a whole number, I add 1 to that whole number, and then I do it at that L plus 1 index. But for both of these, they weren't whole numbers. So nothing too bad to remember on this one. So now I get 23 for this one. So 23 is at the 75th percentile. Number 13, government agencies keep data about the income distribution of the population. The Cook family and the Aoki family live in a county with 5,000 families. The Cook family's income is at the 93rd percentile. The Aoki family's income is at the 44th percentile. Which of the following must be true about the Cook families and the Aoki families' incomes? So we take a look, I'll just go through both of these and argue, or all of these and then argue them. Okay, A, both the Cook family and the Aoki family earn more than the median. So the median is the same thing as the 50th percentile. So, uh, so if you're earning more than the median, then that means that you're above the 50th percentile. Aoki's is in the 44th, so A is wrong. Both the Cook family and the Aoki family earn less than the median income. The Cook family is in the 93rd percentile, so they're above the median. So B is wrong. The Cook family earns more than the Aoki family. So the Cook family is in the 93rd percentile, which means they're above average. The Aoki family is in the 44th percentile, which means they're below average. So the correct answer is C. Okay. And then that means the Aoki family does not earn more than the Cook family. So there's ways to reason around this. Which of the following must be true about the Cook family's income? So about 93% of the families in their county earn less than the Cook family. So if you look back at the definition of percentiles, that's exactly what it means. So if you're in the 93rd percentile, that means that 93% of whatever is smaller, less than, et cetera, et cetera. So we hit the correct answer right on the first one. So it should be A. Okay. Uh, it's not, so it earns, let's see, Cook family earns about 93% of the highest income in their county. That's not it. So that first one is right in line with the definition. This B is, it's not, I would say it's not unreasonable as a guess, but it would be an incorrect guess. The Cook family's income is in the bottom half of the incomes. No, it's in the top half. The Cook family earns $93,000. Nope. And if you're in the 93rd percentile, you're probably well above that, unless, it's a very poor county. Okay, number 14. The heights of eighth graders are modeled using the normal distribution shown below. The mean of the distribution is 59.2 inches, and the standard deviation is 1.9 inches. In the figure, V is the number along the axis and is under the highest part of the curve. U and W are numbers along the axis that are each the same distance away from V. Use the empirical rule to choose the best value for the percentage of the area under the curve that is shaded, and then find the values for U, V, and W. You should have some problems like this in your homework. So, and they already told us that V is under the highest part of the curve, right? So if we're looking at this, well, of course, under the highest part of the curve, that's where the mean is going to be. And it's 59.2. So that makes perfect sense. Now, if we were building the normal distribution and counting out by standard deviations, I could certainly just build this out and start counting by the standard deviations, or you could just do it at the bottom, wherever you want. So 59.2, and then of course you have, let me give myself a little bit more room. These guys going this way and this way. and we're counting up and down by 1.9s. Now I'm going to overkill this on purpose, so bear with me. So this would be 61.1 and then 63 and then 64.9. This is 57.3. Let's see, 55.4, and then 53.5. Living dangerously and just doing the arithmetic in my head. Okay. All right. Now, as far as if we were making the distribution on our own, and again, like I said, I'm overkilling this. This is more than what you need for this problem, but I'm doing the extra just for review sake. Since you're watching me. Wow, they turned that into a straight line for me and everything. So 99.7%. So the special numbers for the empirical rule are 68, 95, and 99.7. And that's what they're asking about right up here. Okay, so we have those all built out. More than what we actually need for this problem. Look at these numbers here. These are giving you context as far as what you could be doing with these numbers that we figured out for the empirical rule. So what are these numbers that I see here are between 56 and 58? Well, 57.3 fits right in there. And then it's not unreasonable, considering they said right up here that U and W are numbers along the axis that are each the same distance away from V. So if this is 57.3, it's 1.9 away. The 61.1 should be 1.9 away, which is exactly what we want. And of course, these are one standard deviation from the mean. So the answer here is going to be the 68%. So now, as far as the correct answers go here, make sure that you're putting the mean there. You're including all of the precision. Don't round these numbers. So make sure that's 59.2 and that this is going to the 10th place. This is going to the 10th place. And when you're adding these up, okay, to get full credit on this. And this is one of these kinds of questions where you don't really have to write down a whole lot. You can mostly just plug in the answers as long as you're being reasonable about it. Make sure that these make sense. So if I'm writing a number here and I have this 56 hard-coded here and this 58 hard-coded here, the number that I'm putting there should be a number between those numbers. Okay. All right, I said a lot about that one, but this really should be a very simple problem where you go down here, you put the mean in the middle, you figure out which one of these special empirical rule numbers go in the other blank spots. All right, time to move on. Okay, number 15. A ride-sharing company has computed its mean fare to be $34 with a standard deviation of $5.30. Suppose that the fares are normally distributed. Complete the following statements. Approximately blank percent of the company's rides have fares between $18.10 and $49.90. And then approximately 95% of the company's rides have fares between blank and blank. Now, you don't have to draw out a whole normal distribution to figure these out. You can get away from just drawing out 7 blanks and then figuring out what goes in those blanks, and then just saying, okay, mean goes in the middle. I don't care if you call it mu or x bar or whatever. So mean goes in the middle. 1 standard deviation away from the mean on each side is 68%. 2 standard deviations away on each side is 95%. 3 standard deviations away on each side is 99.7%. Okay, so they said the mean was $34, and then the standard deviation is $5.30. So I'm just going to add $5.30 going to the right. So I have 39.30, and then 44.60, and then 49.90. Going the other way, I have 28.70, 23.40, and 18.10. That's all the information I need for one of these types of questions, because it's a straight up 68, 95, 99.7 version of the empirical rule problem, and not the one where we go just ever so slightly more granular and we start breaking things up symmetrically and cutting things in half. So how about that? So that first question regarding the 1810 and the 4990, we have those numbers right here. Those are 3 standard deviations away from the mean on each side. So now we have the answer for that part is 99.7. And then for the 95%, well, for 95%, it's $23.40 to $44.60. And I'm just looking at these guys. Okay, to figure this out. Okay, number 16. Below is a graph of a normal distribution with a mean mu equals -3 and a standard deviation sigma equals 4. The shaded region represents the probability of obtaining a value from this distribution that is less than -7. Now, what we're doing with this is we're going to look at this picture and consider the values that they told us about, and we're going to shade the corresponding region under the standard normal curve in this other picture. So the deliverable for this question is just a new shaded region on this empty normal curve. So what we're doing is we're going to take that -7 right here. So that -7 right now, that's an x value. So x is -7. And they've given us the mean and the standard deviation. So they've just said the mean was -3 and the standard deviation is 4. So that's our x value, and what we want to do is take that x value and convert it to a z value to go with this other graph. And I'm going to use that formula, which is in your formula sheet. So z equals x minus mu. Trying to fix my x there. Okay. Over sigma. And just as a reminder, this is z-score equals the data value minus the mean divided by the standard deviation. So that's how all of those symbols translate. Okay. So I have -7 minus -3 over 4. So when I subtract a negative, I can turn that into a plus. So now I have -7 plus 3 all over 4. -7 plus 3 is -4, so -4 divided by 4 is -1. Okay, so now this is telling me that the number that corresponds to the 7, so this -7 on here is mapping to the -1 there. So I can draw my vertical bar. I really thought they would turn that into a perfectly straight line for me. Okay. I about did it on my own there. And then since this one is shaded to the left, we're going to shade to the left. Of course, they tell us that it's less than -7 here. So we would assume that it should be less than -1 on the new picture that we're making. Okay. So doing the best I can with my digital pen. Okay, and that's just being shaded all the way out to -infinity. All right. And that's my final answer. Now, the basic steps for this, of course, read the question and collect the data value. So you're given that data value in two different places. So you can see it on the picture. It's where the vertical bar is on the picture, or it could be that you have two data values if it's an in-between area. So you might have to figure out two z-scores, like one of the examples from class. And then in the problem, they also tell you what the mean is, but you can see that in the picture. What's a little bit harder to get from looking at the picture is what the standard deviation is. So you definitely need to see the standard deviation in the passage up here. So we collect that information, and if you're lucky, you can see right here, it says mean mu. So there's kind of a bit of a codex in some of the test questions if you happen to forget that mu means the mean. So you might be able to reverse engineer some of the stuff if you forget, which is always nice. But yeah, the final product here is this picture. Uh, if you give me the correct picture and I don't see your z-score on the paper, then I won't be too upset. If you give me a picture that is off the wall, or maybe even sort of correct, I can't give you too much unless I see that you tried to do a z-score with it as well. So if you just draw a picture and you don't do anything else and it's wrong, that's not too good. So make sure you're trying to do a z-score calculation or two z-score calculations if it's one of those other kinds where you have the area between two data values. All right. Use the standard normal table at the end of this packet to complete the following. Give your answers to 4 decimal places. Find the area under the standard normal curve to the right of z equals 2.25. So that's literally just looking it up. So, and then since it says to the right, I still have to do just a little bit of work, but I didn't have to figure out the z-score. I can just go look it up. So so the area corresponding to that, straight from the table, is 0.9878. Since it says to the right, my final answer is going to be 1 minus that. Now, instead of typing this into a calculator or doing it into my head, I'm going to remind you guys that there's a shortcut for to the right. And this is the shortcut that I don't write down because I'm only going to write down one way to do it with these because I think the Z table is confusing enough, but I know so many people like the shortcut. I'm going to mention it again. So if it says to the right, the shortcut is this. I can have my Z-score. Now, if I look up the negative of the Z-score, it will give me the area as if I'd done this subtraction correctly. So I'm going to look up negative 2.25. So negative 2.25, and I have 0.0122. Okay, and we're not converting this to a percentage or anything. They said area to 4 decimal places. That's what they want. And if you look at that, or if you did the calculation with your calculator or by hand or in your head, you'll see that if I subtracted that correctly, I will also get 0.0122. Okay, so that shortcut looking up the negated z-score is only for the area to the right. For the area between, I don't have any great shortcuts for that. Okay, so for the area between, I have 2 z-scores. So the question says, find the area under the standard normal curve between z equals 0.10 and z equals 1.50. So I'm going to look up these 2 areas. So I have 0.5398. $1.50, 0.9332. Okay, and then my final area, when it's a between, That's telling me that I'm going to do the big area minus the small area. And you can just remember big minus small. So out of the two areas I just looked up, the 0.9332 is the bigger one. Okay, and we subtract the 0.5398. And I have 0.3934. Okay, so there's my area to 4 decimal places. Number 18, suppose that the lengths of pregnancies are normally distributed with a mean of 272 days and a standard deviation of 8 days. Use the standard normal table at the end of this packet to find the percentage of pregnancies that are shorter than 260 days. For intermediate computations, use 4 decimal places, give your final answer to 2 decimal places. All right, this is one of those cases. All they're really saying is just don't round anything until you get to the final answer. Okay, so there's a lot of information there. What did they actually want us to do? Find the percentage of pregnancies that are shorter than 260 days. Okay, so my data value, my X, is 260. My mean is given right up here, 272. And then my standard deviation is 8. So my z-score, and so I need to be able to look up the area. Data value minus the mean over the standard deviation. So I'm going to have 260 minus 272, the mean, and then I'm dividing all of that by the standard deviation. So I have negative 12, oops, negative 12 over 8. So let's see, that's negative 3 over 2. So that's negative 1.5, and I'm going to just tack another 0 on the end so I don't have as hard a time looking it up. So I'm going to look up the number straight off the table for that, and I'm going to double check and make sure I do what I'm supposed to. So negative 1.5, and I have 0.0668. Okay, and then what did we want? We wanted shorter than 260 days. Well, the number straight off of the table is the area to the left corresponding to shorter. So that's the final area that we want. And then as a percent, This is going to be 6.68%. And that's all I had to do. So the ones where it's the area to the left are just, they just feel ever so slightly easier because you don't have any extra steps. Okay. Yodel Air operates a charter jet service out of an airport and are in a secluded mountain ski resort. The chief security officer for Yodel Air uses a normal distribution with a mean of 630 meters and a standard deviation of 80 meters to model the takeoff distance for the company's X-15 jets in wintry weather. Use the standard normal table at the end of the packet to find the percentage of takeoff distances between 666 meters and 714 meters according to the model. And basically don't round till the end. And then the final answer is going to have two decimal places. And just a reminder, we want to find the percentage. Okay. So this is going to be a between type problem. So now we have an x1 and an x2. So that means we're going to have to calculate two z-values. So we have a mean of 630 and a standard deviation of 80. So my z1, and notation wise, you don't have to be as formal as I am, but z1 is going to be x1 minus the mean divided by the standard deviation. And z2 is going to be the same deal, except I'm going to have x2 minus the mean divided by the standard deviation. So x1 is 666. We're subtracting the mean, which is the 630, dividing by the standard deviation of 80. Okay. And then for the other z value, I'm going to be doing 714 minus the mean, 630, divided by the standard deviation of 80. Okay. So I get 0.45 for Z1 and 1.05 for Z2. Okay. And I need to look up the area for each one of these. So 0.6736 for the 0.45. And then for the 1.05, I have 0.8531. Alrighty. And my final area, it's the big area minus the small area. That's going to give my my in-between area. So I have 0.8531 minus 0.6736. And I get 0.1795. And they wanted a percentage for the final answer. So it's going to be 17.95%. Now, if you're doing this, the area in between, you get a negative value. That's not right. Make sure you're doing big minus small. Now, if you do that and the only thing you did was you got them switched around, then your correct answer is just off by a negative sign. So you have that going for you, but you should not be getting any negative areas in any of these problems. But that is everything that I wanted to talk about. So I'll wish you good luck on test 2, guys. Take care.